Back to my YouTube channel. My name is Noy from ABABA University. Today I am going to show you how you can solve this problem. As you can see, this problem is question number 4 from ABABA University assignment. Before starting this problem, if you are new for educational tube, make sure to subscribe our YouTube channel in order to access every engineering problem and assignment solution and different tutorials that are very important for engineering and different grade level students. They may help in for your high school grade, junior and preparatory skill, and also for university students. So when you come back to this problem is about relative motions of an airplane. We can use the concept of relative motions of an airplane and solve this problem simply. As you can see here, an airplane is flying horizontally with constant speed of 200 km per hour and is towering the greater B, which is gaining altitude if the tower cable has a length r equals 60 meters and theta is increasing at the constant rate of 5 degrees per second. Determine the magnitude of the velocity and the acceleration of the glider for the instant when theta equals 15 degrees. As you can see here, we are given the speed which is constant of an airplane, the radius, and the theta which is increasing at 5 degrees per second, and also the constant angle theta which is 15 degrees. So in order to solve this problem, first we must draw the freeboard diagram like this. Here we have y-axis, and in this direction we have an x-axis. In this direction we have a constant speed v which is 200 km per hour, and here the airplanes make at an angle theta which is 15 degrees. After this, we can extract the given quantities and simply solve the problem. As you can see here, we are given the speed of the airplane which is constant and it is horizontally. It is 5 degrees per second, which means this is the angular speed. We can convert it into rad per second by using a unit conversion factor of pi over 118 degrees, and we will get pi over 36 rad per second. Then we are given r equals to 16 meters. As you can see here, we have given r equals 16 meters, and from this we calculate the instantaneous velocity. In order to calculate the instantaneous velocity, we use this equation omega times r. Omega is already given here and r is given here. Pi over 36 times 16, 5.35 meters per second. Then B is at tangentially at an angle of 15 degrees, which is already given here, and the velocity component along the x-axis is v naught times sin theta is equals to 1.355 meters per second. After substituting the given value v and sin theta, we will get this value, and so the net velocity is this. Since we are given all things, simply you can substitute the value. Here we have given 200 km per hour. 1 kilometer is 1000 meters, and 1 hour we can convert into second, and we'll get this. So in order to calculate the net velocity, we can add with this, and px equals to 56.910 meters per second. Finally we'll get this value. After this, we can simply define the linear acceleration, because here acceleration is the rate of change of velocity or speed. The rate of change of velocity, and the magnitude of velocity is the speed. The speed is already constant, which means initial and final velocity is 0. So the linear acceleration must be 0, which means linear acceleration is equals to r times alpha is equals to r times 0. Linear acceleration is already 0, and we will get 0 meters per second square. But here, as you can see, the angle is changed. When the angle is changed with pi over 36 rad per second square, or 5 degrees per second. So at an angle 20 degree, v naught x is equals to 5.235 times sin 20 degree. Here we can correct it by yourself. It is not 20 degree, it is 15 degree, and we can multiply the value, and we will get 1.790 degree change in. So the change in Vx per second is given as here. We can simply calculate 1.790 minus 1.35. We will get this value, and acceleration in the x is this value. So we can simply calculate the acceleration and the velocity magnitude as stated here. So determine the magnitude of velocity and acceleration of the glider for the instant at an angle of theta is equals to 15 degrees. We will get the